right. So 5.5 was just released, and in it, one of our main features is vector search. So, for those that don't know, let's chat about like what is vector search. Let's start there. Let's talk, what is vector search? Help me understand.
Okay. Well, vector search is a way of accessing what we call unstructured data. If you're a database person, you understand the difference between structured and unstructured data, but it's basically, it's if you want to search and extract information, you need to be able to quantify that information. So if you want to search for images, for example, there's so many different ways you can describe an image. That's what we would look at as an example of unstructured data, because there's a number of different ways to describe it that you could match. Vector search, or vectors, quantify that information. So there's magic that happens with machine learning models that say, if you take a picture, there's red in the picture, so that's going to generate a vector. There's some numeric value associated with red. It's got a person, and then there'll be values that are associated with not just it's a person, but it's a person with a hat, or a person with glasses, or a person with long or short hair. All of those generate vectors. The model that you use is up to you, but that model is what generates those vectors. Then when you want to search, you're going to enter a search string that runs through the same model, and our search now looks for nearest numeric matches. I'm going to defer to Randy on the next level of detail on how that works. And we're going to show you an actual image search that you can access as your own tutorial if you want to build your own version of it.
Absolutely. Yeah, I think that to kind of bring it home is to just give an example. So I've already loaded some images just so you can into Hazelcast Vector Store, just so you can see what they are. They happen to have names that you can sort of understand. So here's a few examples here. So we've got wrenches, wheelchairs, ticks, all sorts of things, all sorts of images loaded into this. But the actual name isn't processed at all. It's just basically taking the vectors or taking the images and turning them into 512 floats, a string of numbers, essentially a vector. So then you're able to, and we're not intending to go over the API here, but this is a Jupyter notebook. We have a Python API, and so you're able to then query just kind of in a natural way. So let's go with I don't know, Hendy mentioned red, so let's try red things and see what comes up. So we do that, and it picks out some red things. So we'll do it a few more times just because it's fun. There's a lot of different ways to describe an image, so it's not just some kind of structured query. Let's see. So we said, musical instruments. I'll try that. Things with legs. That would be interesting. Let's try that. There you go. There's some musical instruments.
This is set up to only return the first 3 results it finds, right? I just
right.
so it's like, why aren't we coming up with more? Right. This example only brings back 3. You can
How are they ordered? The score is based on how close it matches your search, correct?
Yes. This number is a little hard to interpret, but yeah, basically the bigger the number is, in this case, the bigger the number, the closer it is. But there's no real absolute meaning, but in general, things that have a closer score will generally seem more similar. Okay, so let's see. I think I'll just do one more. You said did you say things with legs?
Yeah, try that out.
It'll be interesting to see what it comes up with.
Oh wow,
Yeah, all right, there we are.
Oh my
Hey.
God, what is that? So good.
See, that one's kind of a miss. At least it has a little bit of a lower score.
Yeah.
Like just anecdotally 0.63 seems to be a pretty good threshold for a match. But yeah. So anyway, that's how semantic search works. It doesn't have to be, or vector search. It doesn't have to be a database. It could, or I mean, sorry, it doesn't have to be an image. It could be text, could be used, for example, to for support cases. So instead of just kind of looking for keywords, actually the embedding, the vector can actually capture some sense of the meaning of the case and what it's really about, and find documents that are more likely to be related to it than you would get from just a keyword search. So
This
things
kind
like
of
that.
my next question, and you can stop sharing if you want. In case we're not searching for things with legs randomly, who else would like find this useful? Like, what are other like use case scenarios where maybe there's a little more like value than just me wanting to see things with legs?
Well, I like the support case as a good example, but anything where you wanting to search a document or a set of documents and have context in addition to that, right? Because you can always do, and we've been doing this for years, right? You can bring up a document and you can just do Control F and search for words, but there's no sense of the context of those words, and so or that there's type of search for run and you will match run and running and runner and all of that. So that's being able to have your documents go through this vector, building this vector database. Then when you're searching now, not only are those individual words there, but they're placed in context. So that the vector that's generated for a string of text that includes runner, will have elements and vectors for that add that context to it. So now if I want to do a search for, show me an article about, X, this, I'm not a runner. Reese, you're a runner. What
Yeah.
would you, what would you search for something? Maybe the latest on, what, show me articles about the latest running shoes for overpronators. There you go.
That's perfect.
That's the kind of search that we can do with a vector search, where I could search for runner, shoe, overpronator, but even that, I'm going to get this larger field. Whereas if I put those words in context and the relationships to one another, vector search can capture those relationships in addition to the individual words and give you better matches.
Yeah. Randy, do you have anything on that?
Yeah, absolutely. So that's Hendy covered the whole category that we would call semantic search, which is searching by, kind of more by the meaning than by keywords. And the other thing is, it's finds applications in any kind of anomaly detection. So, you can actually encode or turn into vectors things like security logs, and you can say this log entry is close to another one that was tagged as maybe needs investigation, suspicious, or whatever, or maybe it's near to this user's normal activity, things like that. So you can detect anomalies because in some sense, an anomalous behavior, if the embedding, if you have an embedding that works like this, then the anomalous behavior will be kind of far away from regular behavior. So you can detect anomalies and security breaches, things like that. And then the other category is that people are using now vector databases. It's really an application of semantic search, but they're using vector databases to basically pull up contextual information to feed to an LLM, and that goes by the acronym RAG, retrieval augmented generation. And so yeah, again, it's really just an application of semantic search, but since LLMs are pre-trained and they don't know information that, they don't know information that, things that happened after they were trained or things that weren't available to them when they were trained as private information to your company and things like that, then you can still get them to give answers to questions, for example, that incorporate knowledge that came back from a vector database.
Okay.
I think that's kind of an important point, is that the I mentioned that all that vector encoding that's done using embedding models. Those embedding models are, among other things, large language models. There's a lot of commercial ones available, but like if you're in a financial setting, you're going to take an off-the-shelf one and then continue to augment it for your own use, or you're going to generate one for your own particular application, with your own proprietary data, that's what's going to make you different than everybody else. So the fact that you can use Hazelcast to run those queries, but not only, yes, we'll run those queries and provide you answers back, but then we can also take that output, feed it back into your model to can do this continuous refinement of your model, generate new embeddings, can basically continue this continuous loop of refinement. And because of the way our APIs work and the way that our storage versus compute works, you can have this running simultaneously within a single cluster. Whether you're doing that for research purposes, whether you're actually doing that in production, just the simple fact that you can have this constantly iterative implementation is, that's, and in one platform. I mean, that's one of the kind of use the key differentiator term. That's a key differentiator for Hazelcast, is that we're doing this all inside one system with one set of APIs and one set programming environment. So fewer vendors to, if something goes wrong, you have one vendor that you can go to and say, hey, this isn't working. If it's fewer systems to have to maintain. I mean, there's a lot of benefits to just being able to do it all in one place.
Randy, do you have anything else?
Absolutely. Yeah. Just to reiterate what Hendy said, our pipelines are the perfect way to basically load unstructured data and turn it into vectors and land it in our vector store. And we've already built that integration with 5.5. So we load them and we search them. That's what we can do.
That could be our tagline from now on. Hazelcast, we load them and we search them. It's done.
We'll have to run that by marketing.
Yeah, I think they'll go for it. No, that's great. Perfect. Thank you.